Hello everyone, welcome back to the next video. In this video I will show you how to do post detection on live camera preview in Flutter Android application using MediaPipe. So let's get started. So I have already recorded the video, so I'll just show you guys the recording. So here is my Flutter application running. I'll just give it the camera permission, and here you can see it has drawn the post detection. Now it seems a little bit off. I'm not really sure. Like, I faced this issue for native Android as well. I'm not sure if this is an issue with my device because I'm using a cheap Android device, or it's this issue with MediaPipe, or if I have done something wrong. It is little bit off, but yeah, maybe I'm holding the device as well, so it's not able to fully able to see me. So yeah, do let me know in the comments what do you guys think when you test it on your own devices. Maybe ask someone to record it for you and then see how exactly it goes. Then first you need, as usual, I have created a Flutter application. You need to go to lib, need to go to main.dart, and firstly you need to copy paste all these imports. Here I have created one custom Dart file called my camera view, and this is the my project name. Okay, so Flutter app 2. So if you need to write your own project name over here. So I have imported material as well as services. This is the default code, so I'll simply scroll through this. Here is our home page. So it is a stateful widget. Here we have this method channel of camera permission, and inside init state, if platform is Android, then we just call get camera permission, and inside this particular method we invoke a method called get camera permission, and if the result is true, then we just set this particular variable as true. Then inside the build method, if permission is granted, then we just display our camera view, else we display a text saying give camera permission. Then here is our my camera view.dart. So again I have copy pasted all this code from the documentation. The only thing which you need to know, if platform is Android, then we are displaying this Android view, and the view type is camera view. So same string you need to use it on native Android side as well, and for all other platforms I'm just using this placeholder. Now you need to go to Android, you need to go to app build.gradle.kts, and here inside dependencies you need to add this com MediaPipe task vision dependency, then camera core, camera 2, camera life cycle, then camera view, and then constraint layout. Then you need to go to src main android manifest.xml, and here you need to add this uses feature of Android hardware camera as well as camera permission. Then you need to go to kotlin com example flut app. Okay, sorry, before that you need to go to the assets folder, and here I'll just search for post detection. So I'll just open this particular URL over here. So from this particular URL you can just download these three models. So I think I'm using this pose LandMarker full. Maybe you can try using this pose LandMarker heavy to see what results you get. I've downloaded all three of this, but at a time you can only use one. So don't download all three of this. Like, if you're shipping it to production, just bundle only one of these models which works best for your use case. So here you can see I've included all of this inside the assets folder. Then first you need to create this post LandMarker helper.kt. Now this is the package name which I have copied from main.kt. So whatever you see over here, you can just paste it over here. Now this rest of the code, I'll simply scroll through this. I'll feel free to pause the video and copy this code. I have literally copy pasted all this code from the documentation. So here we are referencing the models or the MediaPipe models which we have downloaded. So in case if you decide to change the name over here, make sure you change it over here as well. Okay, so over here as well, and again I'll simply, here you can see we are setting up pose LandMarker. Here we are doing the detection from live stream. Okay, here we call detect async. So this method is not really required because this is for detecting from a video. We are not really doing it for a video. So again I'll simply scroll through this. Feel free to pause the video and just copy all this code. And this is for detecting from a static image. I have already made a video on for static image, so in case if you want to ignore this, you can do that. And here we return live stream results as well. Here it is for return live stream results error, and these are all the default variables. This is a data class, and this is an interface for on error as well as on results. Then we have this overlay view.kt file. Again, this is the package name. These are all the imports. I'll simply scroll through all of these imports. So feel free to pause the video and just copy all these imports. Okay, so yeah, that's all there is to it. Then here is our main activity.kt. Again, I'll simply scroll through this. So even for getting the camera permission, I have written native code, but if you want, you can use a third-party library for this. So yeah, this is all the code related to getting. And here you can see we are like calling this my camera view factory Kotlin file. And again, this is where we request the camera permission as well. So here is our my camera view factory.kt. These are all the imports again. So feel free to pause the video and just copy all this code. So this is boilerplate code which you have to write every time you want to embed a native Android view inside your Flutter application. So that's what this is. And here we are referencing another Kotlin file called mycameraview.kt. So I've created that file as well. So firstly, these are all the imports. Then here we are extending pose LandMarker listener as well as lifecycle event observer. Here we set constraint layout, preview view as well as overlay view. Here is our background executor service. Here we set the lens facing back. Here is our image analysis as well. Here is our preview camera as well as process camera provider. Here we set variable for pose LandMarker helper, and here you can see we are passing this particular variable, right? So this uses this pose LandMarker full model. So if you see over here, if you want, you can try it with the heavy one as well, but it is big in size. Then here we set all the required defaults. Here we initialize our constraint layout, and we make sure our preview view occupies the entire width and height of the screen. Then for our overlay view as well, we make sure it occupies the entire width and height of the screen. Then inside background executor, we initialize our pose LandMarker. We set up our camera. Then here we just get hold of our camera provider feature. We add a listener. Inside get view, we return our constraint layout. We initialize aspect ratio strategy. Here is our resolution selector. Here is our camera provider. Then here we do camera selector dot builder. Here we initialize the preview view. Here is our image analyzer as well. And then we do it.set analyzer. We call detect pose. Then we unbind our camera provider. We bind it to the life cycle. We set the surface provider as well. Then here we call detect pose. Then in case of error, we just log it to the console, and in case of results, we just pass it to the overlay which draws on our camera preview. And inside on state change, if it is on, resume, and if pose LandMarker is initialized, and then we just set up if it is closed. And inside on pause, we just clear the pose LandMarker, and inside on destroy, we just shut down our background executor. So yeah, that's all there is to it. Thank you for watching. Bye.